The component-based development is something that can be regarded as kind of an outgrowth of the object-oriented development. Component-based development means assembling applications from cooperating packages of executable software. I like that definition. Now, let's see if we can get a translation. First, let me talk about the types of components, and then I'll try to give you an analogy and translation of it. So the basic types of components are things like in-process client components. Those are components that must run from within the container of something like a web browser. We have standalone client components. Those are applications that will expose services to other software. Those might be things like Microsoft Word and Excel as examples. We have the standalone server components, which are processes that are running on servers. They provide services in standardized ways. Examples would be things like the Distributed Component Object Model, or OMG's Common Object Request Broker architecture called CORBA. And we have in-process server components, which are components that run on servers within containers, sort of like Microsoft's transaction server. Now, here's the thing about a component. I'm going to talk about a type of component that if you've used Windows anytime in the last 12 years, you know what I'm talking about. These are files that end in .dll, Dynamic Link Library. And I'm going to guess that maybe in your life you've played a game of solitaire. Of course, never while at work. Now, when I open up that solitaire game, it presents to me a deck of cards, 52 cards, 4 suits, 2 through ace or ace through king, however you want to look at it. And it's got, the ability to shuffle cards and all that sort of stuff. So the programmality that does that keeps track of the types of cards, the suits, the shuffling. If I wanted to then develop a new card game called Hearts, you may have seen that as well. Well, it uses the same deck of cards. But rather than my having to program the cards for solitaire and then reprogram the cards for Hearts, why not have a standalone component that can provide the function of cards for all of those? We call that a COM object, a component object model. The fact that it can exist spread out on many different application servers makes it distributed, so that's where the name DCOM comes in. And that's very similar to the concepts of from OMG with CORBA. We also have the web-based application development. Now, this is a new software development approach designed to achieve easier and more effective integration of code, especially between different enterprises. The beauty of it, and the reason it works so well, is that we all have the same clients, right? A web browser. Now, in the past, software written in one language would need some sort of application programming interface, an API, to integrate with software modules in other languages. A web-based application uses a common language so they can communicate back and forth, known as XML, the extended or extensible markup language. Your web-based application development that uses XML can generally work on any operating system that understands XML. Another advantage is that the modules are coupled loosely, which means that one module can be changed without having to change all the other modules of the program. Now, if you think about it, the reason it works so well across platforms is because all I need is a browser that can open up. And every platform I know of has some sort of browser. Even for Windows, we have a variety of browsers to choose from. And I'm certainly not going to get on the bandwagon of IE or Firefox or Chrome or any of these other ones. It doesn't matter to me at this point, right? Because they're a browser. And if we write the code to speak to the browser and we use a common language of XML, then any Macintosh with their operating system, my Droid phone, your iPhone, all these things have browsers. So it really is cross-platform development. Software reengineering is a process of updating an existing system by basically extracting and reusing its design and program components to come up with a new type of system. Reverse engineering is a process of studying and analyzing an application to see how it functions, and then using that information to develop a similar system. We do this through a process called decompiling the executable code into source code, often assembler language, and then analyzing that program. In fact, in black box testing of an application, it's usually done through the process of reverse engineering. I made a claim earlier when it came to the top secret nature of the source code of Windows. And I'm not here to say it's right or wrong or anything else. But I made a comment that says it doesn't matter because we already have the source code of Windows. And we do because we have the Windows program running. They are a series, collections of executable codes. We can decompile any executable code that we want to. And as long as we know what we're reading, we can analyze the program. In many ways, that's how hackers are finding ways to exploit vulnerabilities. They'll actually wait for a new security patch to come out, and they'll disassemble that or decompile, almost virtually the same thing, that particular patch to see what it's fixing. And because they know what it's fixing, they can go look and see what they can do to attack people who haven't fixed it yet.